Okay, now I have considered this is as my pivot point, and I have to gather what is the anti-clockwise forces. This is anti-clockwise forces, and these two are clockwise forces. So if I apply the equilibrium condition to this system, we can apply the principle of some momentum, which says for any point in a system, the sum of anti-clockwise moments are equal to sum of clockwise moment at the same point. So obviously starting from the anti-clockwise, f multiplied by this distance, which means let's say f multiplied by 0. So I have to convert this one into meters, right? So which means divide by 100 or divide by 100, right? And for the other side, 15 multiplied by 16 divided by 100, and 50 multiplied by 35 divided by 100. Okay, these are the values, right? Then I can write down 15 multiplied by 16 divided by 100 plus, there should be like this, 15 multiplied by 35 divided by 100 should equal to what? Should equal to f multiplied by 4 divided by 100, right? And first, in the first instant, since you learn about solving the equations, right? Can you find out any common terms in this equation? Any common terms? What are the common terms in this equation? So everyone has divide by 100 term, right? So I can just cancel out that. So that will basically give us the answer. Okay, what is the 15 multiplied by 16 really? 15 multiplied by 16, it is 240, right? Then 15 multiplied by 35, 1750, 1750. And if you add these two together, 1750 plus 240, it is 1990 divided by 100. Answer is 497.5. Answer is 497.5. What is it newtons or meters? 0.5, this should be in newtons, okay? This value, right? So here it is 4F, you have to take out the 4. Right. So it is obviously the answer in the first case, right? 497.5, it more likely to be equal to 500 newtons. Which means that to lift a 50 Newton weight, right? To lift a 50 Newton weight, the bicep, if it is perfectly perpendicular, the bicep will give 497.5 newtons of force, right? However, this is only applicable when the bicep is perfectly perpendicular, okay? Only in the perpendicular case. In the other case, it is different, right? This is also another question which actually kind of a question actually asked for the MCQ question for a A-level past paper. Okay. In this question, wheelbarrow is loaded as shown in figure 4. we need to find out the force that the person needs to exert to hold the wheelbarrow's legs off the ground, right? Which means what is the thing we need to find? Look, let's look into the figure. Right. What is the missing force? Can you identify what is the missing force in this free body diagram? They are asking for this value. Person has to pull up the wheelbarrow, to get rid of the wheels off the ground. And what is this 400 Newton means? It is the weight of this wheelbarrow, right? In the field condition, it is the weight acting on the center of gravity. And from the center of gravity and to the pivot point, I mean the true center of the wheelbase, you have all the distances, right? What is the missing force? Now, when you apply the P force, these legs are not connecting to the ground. The only thing connecting to the ground is now the wheel, right? What is the missing force here? The missing force is actually from the ground to upward. This is the reaction force, right? As I explained earlier, there's always action and reaction, right? According to the Newton's third law. So this is the exact same. Why I cannot put the wheel force in here? Because this legs of the wheelbarrow is not touching the ground, because we are applying the P force. Okay, now shall we try to find the P force and this reaction R force? Okay. First of all, to find out the P value, you can consider this as the pivot point. Okay. If this diagram is too much complicated for you, then you can just draw a simple diagram like this. This is the pivot point, and there's 400 newtons in this direction, right? 400 newtons in this direction. Here is the P value, and that's it, right? This is also the R value if you want. And we need to consider the distances as well. You can write down the R, P, and this is 400. From the wheelbase to 400, this is 0.2, and this distance is 1.2 plus 0.3, which means 1.5, right? This is 1.5 meters. Am I correct? If this is 1.2, yes, 0.3, which means this is 1.8. Sorry, 1.5. Sorry, it should be 1 meter, right? Yes, it should be 1 meter, not 1.2. It should be 1.2 meters. Right, however. Okay, we'll start to find the P value now.
Should be 1.5 because 0.5 minus 0.2 equals 0.3. So 0.3 plus 1.2 equals 1.5.
1.5. No. The issue is with the drawing. Now, can you see if this is 0.5, this cannot be 1.2, right? I mean, there's no such distance in a wheelbarrow. So 1.2 means from here to here. That is also why I confused in the first case. Can you understand? This distance is 1.2.
Right.
Otherwise, if this is 1.2, they will mention it like this, you know.
Yes.
Okay. So 1.2 minus this means here to here it is 1 meter. Right. Okay, obviously. Let's look at the P1 from this diagram, okay, this point. So which means I don't want to consider about the reaction force now. I only need to consider two forces, right? The anti-clockwise one is the P1. P multiplied by up to this point, it is in this direction. Can say P multiplied by 1.2, the whole distance, and the other one is the clockwise direction, this 400 newtons. So it is 400 multiplied by from the period point, it is 0.2. Okay, that's it, right? 400 multiplied by 2 means it is 80. 80 is equal to, according to the principles of equilibrium moments, uh, these two moments should be equal to each other. So P multiplied by 1.2, which means 1.2 times P should be equal to 80. Then P should be equal to 80 divided by 1.2, which gives us the answer of 66.6. 66.6 newtons. And the second question is calculate the force exerted by the ground on the legs of the wheelbarrow taken both together when the gardener is not holding the handle. Now, in the first scenario, when it is holding, if they are not holding that, then again asking the reaction force, right? Okay, in the second case, however, there is no force like that. This holding force. Then when you draw the free body diagram, you only have the weight of the wheelbarrow and the reaction force from this the legs of the one and the reaction force from the ground. Can you understand? Only these three forces, right? When there's no handler, when the person is not holding it up, this is one force, this is the second one, this is also there, the legs are now holding to the ground, this is another reaction. Only these three forces, right? Now they are asking about what is the calculated the force exerted by ground on the legs of the wheelbarrow taken both together. Both together means what? What are the forces exerted by ground? This reaction force and this reaction force, right? Can you give the answer? What should be the value of these two forces together?
It
It
has to
should
be
be
equal to 100 Newton.
400, right? Exactly. It should be equal to definitely 400. If you want to find, I mean, now if you want to separately find the value, however, when you take it together, it is 400. But if you take them separately, uh, they have two different values. However, in order to find those two values, I mean, you can see principles of moment, that is the most used question, most easy to use question, because if there are two unknown variables with one known variable, you can use the principle of moment. Why? When you consider point in here, what happened? We don't want to know about the x1. Then you can make a connection between these two, right? Unknown value, known value, and unknown value. So you can find this y value first of all, then you can apply it in here. Then again apply, there should be another correction between these two forces. Okay, we'll quickly find out that value as well. So I don't know this one, right? So I'll consider here. Then I will first of all find this P value. Okay. Now only two forces, right? P around this one, P multiplied by distance is 0.5. Am I correct? This is the 0.5, and 400 is in the opposite direction. 400 multiplied by, from here to here, it is 0.2. 400 multiplied by 0.2. Then to find the p-value, you have to divide this side by 0.50, right? So point to point divided, and 5 times 80. 80 times 2 means 160. 160. P-value is equal to 160 newtons. Then what is this R value again? Just 400 minus 160, right? Because this is in equilibrium. 240. So these are the two answers if you want to find it separately, right? So here is also another question. These are the traditional scales, right? If you remember the oldest type of scale, they are using actually, there are sliding masses, right? And we have to hang our object to be weighted in one side, and we have to automatically balance. So remove this 10 gram mass, slide around here, 100 grams around here or here, then you can balance it out, right? And in this question, they are asking calculate the value of the mass m, right? Actually, these old scales are using the principle of moment to find out the mass, right? What is the m value, right? So m value should be equal to what? If you consider this pivot point, right? These two are applying downwards and distances are also given. You can multiply the 100, convert this one into kilograms, okay? Kilograms, and then you have to multiply it by 10, right? Can you remember? So this is a mass only, okay? The m value is 100 grams. Then what is the Newton value? What is the weight of this object? How to find out that? 100 divided by 1000. Why is that? To convert into kilograms multiplied by the gravitational acceleration. So another 10. Then the weight of the object is 1 Newton, right? 1 kilograms means 1 Newton. 10 grams means then what? 0.1 Newton. Yes? 0.1 Newton. So how to find the m value? 1 Newton multiplied by 30 divided by 100. 0.1 Newton multiplied by 45 divided by 100. And it should be equal to m multiplied by 20 divided by 100. And you can just find out the value, right? Okay. And then you can find out what is the one advantage of this method of measuring mass, right? And also you can determine the upward force of the pivot on the bar, which means this force, right? Once you find out the x value, you can take this one as a pivot point, then consider this one as R or something, then again do the same procedure. And this is the last question I want to discuss, right? So still I have considered the very simple forces. It is either up or down, right? It is very easy, obviously. However, in the A-level exam, these forces might be having some certain angles, right? So you don't need to worry about the angles because you already know the how to resolve the forces, right? You just have to concern, you can remember the F1, F2 in this figure, F4, they can very easily applicable. However, as for the linear equations, right? As for the linear equations, we have hard time finding the exact angle, FO, right? So in this case, if you consider this P as, let's consider this P as a pivot point, okay? Now you can see this is 10 newtons is a clockwise, this is anti-clockwise, this is the not considered because it is going through the pivot point. What about this F3 10 newtons? F3 10 newtons. The line, what is the line of action of the force? Now, obviously, it is also supporting the clockwise direction, right? These two are clockwise direction, this is anti-clockwise direction. Now, however, there's a problem now. When you want to find out that clockwise moment, you can easily find out 10 multiplied by 25 divided by 100, right? However, what is the distance? Now you can see this is the line of action of the 10 Newton and this is the perpendicular distance. Then what about the 10 Newton in the F3? This is the line of action and this is the perpendicular distance. So how to find out this distance now? Very easy, right? If this is 30 degrees, if this is a right triangle, what is this distance? It is 50 centimeters. So you can apply the sine function, right? So opposite divided by the largest side. So it becomes 50 sine 30 and you can get the answer. And that is the force, right? You have to multiply to get the clockwise moment. 10 Newton multiplied by this x value. Okay. I hope you got the point, right? Right, you can see, calculate the point P, right, moment of the force about point P, which means, right, for each force, calculate the moment, okay. For this point, the moment is 10 multiplied by 25. It's for this one, 10 multiplied by that x, right? For this point, it is 5 multiplied by 100 centimeters. State whether each moment is clockwise or anti-clockwise. You can obviously understand that clockwise, anti-clockwise, clockwise. Whether or not moments are of the force are balanced, right? You can check this one, right? How to check whether these two walls are balanced? Uh, Considering one point, you can consider again clockwise sum should be equal to the anti-clockwise sum. If these two sides are summing up with each other, they are taking the correct same answer, then this is a balanced um, uh, system, right? Right. Okay. I'll only do the, yes, I'll only do up to this point. I'll send the questions as well. And the next week we'll start from the talk of a couple, which means it is similar to the moments. However, if I briefly explain this talk means, if any moment around a pivot point satisfy these three conditions, it become a couple, right? Pair of forces like is called as a couple. For example, uh, the easiest example, I think, if you consider two forces, if they are equal in magnitude and parallel but opposite in direction and separated by a distance of d, the same distance, this turning moment or couple is called as the torque, right? For example, when you drive using the wheel, right, you can see these two forces are applied using the hands of the driver, and you can see the force values are equal to each other, they are parallel to each other, and they are in the opposite direction, and from the pivot point they are located in the same distance, right? Same distance, here to here and here to here, it is all 0.2. In this case, instead of going for like considering this pivot point and considering this clockwise moment and this clockwise moment, since it is a couple or torque, you can just multiply one force. Consider one force, and only if this is a couple or torque, okay? Only this is satisfying those three conditions. Then you can directly get the answer as 15 multiplied by distance between the forces. Distance between the forces is actually 0.4 meters. But in the other moment cases, what we have done, we only take distance from pivot point to the one distance. So 15 multiplied by 0.2 plus 15 multiplied by 0.2. However, in this case, since this is satisfying those three conditions, the equation just become different. However, it is the same thing. One force multiplied by distance between two forces, not from the pivot point. You can obviously see if you even use the principle of moment, you will get the exact same answer. Okay, it is just a matter of these three conditions: equal in magnitude, parallel but opposite in direction, separated by a distance, right? If you consider the old method, old moment, principle of moment method, 50, you can see that wheel is turning into the clockwise direction, right? So one force 15 multiplied by 0.2, 15 multiplied by 0.2, obviously it is 6 Newton meters in the clockwise direction. Since this is a torque, since it is satisfying the torque or couple values, you can just take one force multiplied by the distance between the forces. So it is 0.4, which gives the exact answer, right? Just the definition is different. Eh? Torque of a couple is one of the force multiplied by perpendicular distance between the force. Right. Here we have one question we can do. The driving wheel of a car traveling at a constant velocity has a torque of 137 Newton meters applied to it by the axle that drives the car, which means in here, in this side, it is the full moment is 137 Newton meters. Okay, and the radius of the tire is 0.8 meters. Calculate the driving force provided by this wheel. Driving force provided by this wheel. Okay. Okay, if I apply the theory of this torque, actually this is also a couple of torque, right? Then what is the equation? Whether there is a one force here and there's another force here, these two are same magnitude, different directions with the similar distance, right? Then what is the equation? 137 Newton should be equal to one force, which means one F. We'll consider this as the F. One force multiplied by the distance between forces. which is actually not the radius, it is the diameter, right? So it should be 0.36. And now if you take F outside, 137 divided by 3, 0.36, and this is the answer, right? This is the answer. Yes. Okay.